Okay, concept 22 is identifying conic sections. So given an equation of a conic, we need to determine what type of conic it is. So we have 4 types. We have parabolas, circles, ellipses, and hyperbolas. So in number 1, let's just look at the multiple choice and go through one at a time. So in the first equation, we have both variables squared. That's one thing we need to look at. And the second thing we need to look at is the coefficient in front of each of those. So the fact that both variables are squared tells us that it has to be either in a circle, ellipse, or a hyperbola. And because one of the coefficients is positive and one is negative, the only option here is that it is a hyperbola. So that is actually the answer. But let's look at these other ones just to go through the differences. So in part B, both variables are squared. So we do know it's either a circle, ellipse, or a hyperbola. And looking at the coefficients, they are both positive, and they're both the same coefficient, 1. So this has to be a circle. In part C, we have both variables squared. So again, it's either a circle, ellipse, or hyperbola. But we have both positive but different coefficients. So they're both positive, but since they're different, unlike part B, this is an ellipse instead of a circle. And then in D, only one of the variables is squared, so this is a parabola. All right, in number 2, again, multiple choice, which equation represents a circle? So in this first problem, we have both variables squared, but different coefficients. So this is not a circle. In part B, again, we have different coefficients in front of the x squared and the y squared, so this is not a circle. In this equation, let's move the y squared over so that it looks more like graphing form. This is actually a hyperbola because we have a minus. One of the coefficients is positive, the other is negative, so this is a hyperbola. When we get to this equation, we do have the same coefficient in front of the x squared and the y squared, so this is a circle. If you wanted to write this in graphing form, you could multiply the whole thing by 4. And then you would actually get x squared plus y squared equals 4. But again, even in graphing form, they both have the same coefficient. So as an explanation of why, both variables are squared. Same coefficient in front of both. All right, and then in part 3, or number 3, which statement describes the graph of this equation? So we can see A and B refer to this as an ellipse, C and D refer to it as a circle. We can look at the squared variables and notice that the coefficients are exactly the same, 1 and 1. So we know that it's not an ellipse, so we can automatically rule out A and B. Now we just have to decide whether it has a radius of 25 or a radius of 5. If you change this to graphing form, we'll be able to tell what the radius is. So we can use our completing the square process to get it in graphing form. Let's group the x's and group the y's and move the 15 over to the other side. And if we complete the square for the x's, this is 9, okay, 6 divided by 2 squared. 2 divided by 2 squared is 1. And over here, we need to add these values here to the other side, so 9 and 1. And so simplifying this, we get x plus 3 quantity squared, y plus 1 quantity squared, and over here we have 10 plus 15 is 25. This side of the equation for a circle is r squared. So if 25 is equal to r squared, that means r must be equal to 5. So the radius is 5.